Okay, hello everyone. Okay, this video is a supporting video. Okay, it's supporting video for the shear stress distribution in beam. Okay, so and in the last video I explained why there is a shear stress distribution in beam at the flange part, and the web part. Okay. Okay, in the flange part, we use a top view. We use top view to look at this section and this section. Okay, this section and this section. Okay, and then we say that when we look at this side, because this section, okay, sorry, this section experience this compression force. Okay. And also this section experience more compression force. Therefore, at this side, it will have larger shear force to resist the compression force compared with the left hand side. The left hand side, because this section only experience or is subject to a lower compression force. Therefore, it will generate lower shear force here compared with the right hand side. Okay, and then I say there is the cross section area of these two shear force is the same. Okay, so that's why if you have larger shear force, you will have larger shear stress. Okay, and I think some people would be wondering why did I say the cross section area is the same for these two forces. It's hard to imagine. Okay, so I focus also. Okay, in this update slide, I make the bolt line here. Okay, when we're trying to analyze the shear force balance, we look at this the bolt part. Okay, when we want to analyze the shear balance, we look at this bolt part. Okay, and this bolt part is hard to imagine in 2D. Okay, so I make a 3D picture here. Okay, in this bolt part actually is the real 3D picture is here. Okay, so when we talk about the shear force at this side, it means the shear force at here. Okay, and I say in order to have the shear force balance, it will generate a shear force on horizontal. It will generate horizontal shear force below at the bottom of this element. Okay, so that's the that's the element we are looking for the shear force balance. Okay, so and this element, no matter the element here at the left hand side and right hand side, this element size is the same. Okay, this element size is the same. That's why if you have larger shear force here and here, that means you have large shear stress. Okay, and the same thing here. When we analyze the shear stress distribution at the web part, okay, we focus on this section and this section. Okay, and at the bottom of this section, okay, at the bottom of this section, because the right hand side, at the bottom of this section, at the right hand side, it experiences more compression force. It's experience more compression force. Okay, that's why the shear force at the bottom at the right hand side is way larger than the shear force at the left hand side. Okay, and then when we want to do the shear balance, we focus on this bolt part. We focus on this bolt part, and this bolt part actually is a 3D element. Also, I also make a 3D picture for this element. Okay, actually this is a 3D picture element. Okay, so okay, we say you will have the shear force here. Okay, general shear force here to resist the compression force. Okay, and at the same time, because the shear balance, there must be a shear force here to make the shear balance. Okay, and no matter in the left hand side and right hand side, okay, the element size is the same. Okay, so when you have large shear force at the bottom, okay, that means you have larger shear stress. Okay, because the element size no matter at the left hand side and right hand side, they are the same. Okay, you have larger shear force here, that means you have larger shear stress here. Okay, so also you also have larger shear stress at this side. Okay, that means you have larger shear stress as this side. Okay, so that's why I make this supporting video to make this element more to make this element here element here more clear. Okay, so that's for the video for the shear stress in beam. Hope you have more understanding on shear force distribution in beam or shear flow in beam. Okay, thank you for your watching. Bye bye.